everyone. This is Dr. Kalpana Lokhande from Department of Applied Mathematics, Pliyadashini College of Engineering, Nagpur. I am here to discuss about the topic gamma function that comes under Unit 1, Integral Calculus 1 of Applied Mathematics 2. This topic is actually foundation for the entire integral calculus. It is having vast applications, especially it can be used to evaluate definite integrals which are otherwise quite difficult to evaluate by usual analytical methods which are available to solve the definite integrals. Starting with the gamma function. Gamma function is denoted and defined as gamma n is equal to integral 0 to infinity e power minus x to the power n minus 1 dx. The notation for gamma function is inverted L. The integration on right hand side converges to positive n only. For positive n only. Standard results. Now these are some standard results of gamma function which we need to remember while applying it to solve or evaluate the definite integrals using gamma function. The first standard result is gamma n plus 1 is equal to n gamma n. Second is, if n is positive integer, gamma n plus 1 can be evaluated as gamma n plus 1 is equal to factorial n. Third, the value of gamma 1 is 0 factorial, which is equal to 1. Fourth, the value of gamma 0 is infinity. Fifth, if n is negative fraction, then to evaluate gamma n, we make use of the relation. We rewrite the relation gamma n is equal to gamma n plus 1 upon n. Sixth, value of gamma 1 by 2 is under root pi. The seventh, that is the last result which is to be remembered, is gamma n into gamma 1 minus n is equal to pi upon sin n pi. The proofs of all the above standard results can be later on discussed. Let us first try to understand how it is applied to solve definite integrals. For example, let us evaluate the integral 0 to infinity e to the power minus x square dx. Starting with the given integration, here we first try to reduce this integral to the standard form. What is the standard form of gamma? It is integral 0 to infinity e power minus x to the power n minus 1 dx. The value of this integration is gamma n. Now to evaluate this integral, what we do, we try to reduce it to standard form is for exponent of exponential function. Here the coefficient should be 1 and the power should also be 1, and therefore we substitute x square is equal to z, so that x is equal to z to the power 1 by 2, taking under root on both sides. Now x equal to z to the power 1 by 2 gives us dx is equal to 1 by 2 into z to the power minus 1 by 2 dz. Also, whenever we go for any substitution, we have to check whether there is any change in the limits of integration. So, if we put x equal to 0 here, we will get z equal to 0. And for x tending to infinity, z will also tend to infinity. And therefore, our now integral becomes integral 0 to infinity e to the power minus z. In place of x square, we put here z, and then in place of dx, we put here 1 by 2 z to the power minus 1 by 2 dz. Adding powers of z and taking this constant out of the integration, it now becomes 1 by 2 integral from 0 to infinity e to the power minus z, z power 1 by 2 dz. Now comparing with the standard integral, that is gamma n is equal to integral 0 to infinity e power minus x to the power n minus 1 dx. The value of this integral is now gamma 3 by 2. To evaluate the value of gamma 3 by 2, we use gamma of n plus 1 is equal to n gamma n. Using that, value of gamma 3 by 2 is 1 by 2 gamma 1 by 2. And the value of gamma 1 by 2 is under root pi. So substituting these values, the value of integral 0 to infinity e to the power minus x square dx comes out to be root pi by 4. Thank you. This is all about gamma function.